A researcher wants to compare the proportions of male and female participants who prefer a certain brand of soda. In a random sample of 200 males, 60 preferred the brand, while in a random sample of 250 females, 70 preferred the brand. At a significance level of 1/100th or 1%, what is the conclusion of the test? Is it A, that we can reject the null hypothesis and conclude that the proportion of males who prefer the brand is different from the proportion of females who prefer the brand? Is it choice B, we fail to reject the null hypothesis and conclude that the proportion of males who prefer the brand is the same as the proportion of females who prefer the brand? Is it C, we cannot conclude anything about the proportions of males and females who prefer the brand? Or is it D, none of the above? In order to begin, we have to construct our null hypothesis and our alternative hypothesis. Well, our null hypothesis should be that P sub 1 is equal to P sub 2, meaning that the proportion of males who prefer the brand is the same as the proportion of females who prefer the brand. And then the alternative hypothesis will be the exact opposite of this, that P1 is not equal to P2. So now let's look at the given information and try to calculate some of the values that we will need to construct our confidence interval. The first piece of information that we need to find is the proportion, or our P1 hat value for our first random sample. So in that random sample of 200 males, 60 preferred the brand. So that means P1 hat is equal to P sub 1, which is equal to 60 divided by 200. And if we divide both the top and bottom by 2, we'll get 30 over 100, which is 30 hundredths, or 3/10. Now let's look at, or try to find, our P2 hat value, which is equivalent to P2. And that's going to be the 250 females. That's our total. And out of them, 70 preferred the brand. So we have 70 divided by 250. We can divide both the numerator and denominator by 10 to cross out the last set of zeros. Now we have 7/25ths, which is equivalent to 28 hundredths. So that will produce 28 hundredths as the decimal. We also know our n values. So n1 is 200 and n2 is 250. The last piece of information that's important is the significance level. The significance level of 1/100th or 1% means that we need to construct a confidence interval that we are 99% sure of. That makes the z star value to be 2 and 58 hundredths. And now we can substitute all of these values in to construct our confidence interval for our two sample z interval for two proportions. And that formula is P1 hat minus P2 hat in parentheses plus or minus z star times P sub 1 times 1 minus P sub 1 all divided by n sub 1 plus P2 times 1 minus P2 all over n sub 2. Well, we know our P1 hat and P2 hat values are 3/10 and 28 hundredths respectively, so we can substitute them in. We know that our z star value is 2 and 58 hundredths times the square root of 3/10 times 1 minus 3/10 is 7/10 divided by 200 plus 28 hundredths times 1 minus 28 hundredths, or 72 hundredths, all divided by 250. And now we can reduce the 3/10 minus 28 hundredths to be 2 hundredths plus 2 and 58 hundredths times the square root of 3/10 times 7/10 over 200 plus 28 hundredths times 72 hundredths divided by 250. So if we substitute what was in the square root into a calculator, we get about 43 thousandths. And if we add 2 and 58 hundredths times 43 thousandths to 2 hundredths, we get about 131 thousandths. And when we do the subtraction, we get about negative 91 thousandths. So that makes the confidence interval become negative 91 thousandths to 131 thousandths. And this interval does contain the value of 0. Therefore, we fail to reject the null hypothesis, and P1 and P2 can be equal to one another. So therefore, the answer to this problem is choice B. We fail to reject the null hypothesis and conclude that the proportion of males who prefer the brand is the same as the proportion of females who prefer the brand. Answer choice B.